This lesson is on the equation of a line and what that equation tells us. So the equation of a line, there's actually many forms, but the form that you will be most familiar with is this form over here. Y equals mx plus b. Sometimes you will see plus c, sometimes you will see plus k. I prefer b or c. For our class purposes, we're just going to say y equals mx plus b. Some definitions or pieces of information that we're going to need as we go along is first the concept of an intercept. So I'm just going to do like a quick sketch of the Cartesian plane again, just so you have it here to look at. So there's my x-axis and my y-axis. So the y-intercept is where, and we're not going to say line only because this definition is true for all kinds of graphs. So we're going to say where the graph meets or intersects the y-axis. So likewise, the x-intercept would be where the graph meets the x-axis. Now, remember what x and y are, right? So they're axes, and in a point, we will have an x coordinate and a y coordinate. So if I'm on the y-axis, if I'm here on the y-axis, that means that I've not moved horizontally at all. And so that would mean that my x value is 0. So the y-intercept is where x equals 0. And then by the same logic or understanding, the x-intercept then would mean if I'm on the x-axis, so if I'm here, then I've not moved vertically, which means that my y value would be 0. Okay, so that's just an understanding of what those terms mean. Now, what we're going to do is we're going to look at what does the equation of a line tell us. So here we're just going to go through a few examples where we're going to graph some lines, and here we're going to graph using a table of values. But for the rest of this unit, once I've taught you how to graph a line using various methods, table of value method is not what I want to see you use. The table of value method is important because when we are met with a function that we don't know how to graph, we can use our table of values to help us. So the way a table of values works is it's a table. And remember, your x values are independent. So we pick our x. So here I'm just going to pick for these examples, we're going to pick the same x values all the time. Oops, that went wrong. We're going to go from -2 to +2. And so in the definition of my line, y equals x. If x is -2, I substitute that in. It'll tell me that y is -2. And then I just complete the rest like that. Now what we're going to do is we're going to do the table of values, and then we'll plot points and graph them. So the next line that we will do is y equals x plus 3. So remember, we're going to use the same x values all the way, so that doesn't change. And then my y values, we're going to substitute in. So just use your calculator. And so in your calculator, you're going to say -2 plus 3, because remember, you're substituting the value of x into the definition of y. So you're just going to go -2 plus 3. And that's going to give you 1, then -1 plus 3, etc., etc. And that's what you're going to have. We're going to do one more. So here we're going to get -4. Now what we're going to do is we're going to graph our lines. So I'm going to create a system of axes here. And I'm just going to label my axes now and put my values in. Okay, so in plotting our line, we don't really need to plot every single point, because 2 points will define our line. All we really have to do is just put in our points, and then we can join them, and that will give us our line. I'm going to color code my graph. So what I'm going to do is I will draw my first line in blue, I will draw my second line in orange, and I will draw my third line. I think I will use this magenta color. Okay. So what I'm going to do is I'm going to plot just the first point and the last point and then connect them. And you can do the same thing. And what I would suggest is do that for all 3 graphs and then check whether you have the same thing that I get. So press pause on the video, do that, and then continue and like have a look at it. And then if you're getting something wrong, then you can kind of listen, go back and check what you're doing incorrectly. So the first point is -2 and -2. So that's over there. Remember, it's x and then y. The next point is 2 and 2. So that goes up there. And then we just need to connect it with a ruler. So you take your ruler and you make sure that you have placed your ruler so that it goes across those points. And once you've done that, you just draw your line to connect them. Once you have your line drawn, you can just extend and put your arrowheads. I'm not labeling my line because I'm doing it all in different colors. If you don't have colors and you're just graphing in pencil, then what you will do is you will number your line itself. So this is L1. So notice how it's a subscript 1. This is L2 and this is L3. And then what you would do is at the end of your line here, you will label that L1. Okay, so the next one is my orange graph. And so the first point is that one over there, and that's at -2 and 1. So I go to -2 and 1. And notice I'm using 2 squares as 1 unit because my squares are really small. And so I've spaced it out like that. And then the next point is 2 and 5. So there's 4 and that would be 5. And then again, all you're going to do is line it up with your ruler. Get your ruler to line up so it passes through all those points. And you're just going to connect them. And extend past, because we don't want to draw like a really small line segment. We'd like it to be a nice looking line. And I'm just going to label that as well in case you are also working just in one color. Then you can just label them. That differentiates it. And it looks a lot neater than writing the whole like definition of the line. Instead of writing y equals and all of this writing on your graph, if you label it in your working at the top as L1, L2, L3, and then you just label it like that at the bottom on the function on the graph itself, it just looks a lot nicer. Okay, next point for the next graph. So -2 and -4. And then 2 and 0. And then all we need to do is line our ruler up so it passes through those points and connect. And then of course we're just going to have to draw our arrowheads. And that is line 3. Okay, so we're going to now write out some observations and then draw some conclusions or conjectures based on those observations. So here we're going to talk about the line itself. We are going to put in what we notice as our y-intercept. Or let's do this. Let's write down first what our b value is from our mx plus b, and then what is the y-intercept. Okay, so the first line was just y equals x. I'm going to put this. Okay, so in y equals mx plus b, in this graph here, or in this line, remember b is what I add, right? So y equals mx plus b. In this one, we have a y equals mx and then there's nothing there, right? So in math, nothing, meaning we're adding nothing. So mathematically, nothing means 0. Now let's look at the function itself. Remember, your y-intercept is where your line will intercept with the y-axis. So I'm going to like just kind of draw out the y-axis for us, or like highlight the y-axis for us. So you can just see. That's your y-axis, right? So you want to look on that line and figure out or observe, write down, where does L1 cut? Now you can see L1 is meeting the y-axis right there. Okay, right over here. And that point is where y is 0. So now let's look at the next line. L2, which was y equals x plus 3. My b value is 3. And if I look at my y-axis, I can see that that is where my line is cutting the y-axis, and that point is at y equals 3. Okay? So I'm actually going to write it like this for us. I'm going to write y equals 0, y equals 3, and then let's do the last line, which was y equals x minus 2. Over here, if I look at my graph, my line 3 is cutting the y-axis, my b right there. So my b value, in the mx plus b is negative 2. And down here, I'm cutting the y-axis at y equals negative 2. Now look at this table. Can you see a relationship between the b value and the y-intercept? So just like think about that to yourself for a second. I'm going to pause for like 30 seconds. All right, so what I'm hoping you would have noticed is that in y equals mx plus b, the b value is the y-intercept. Okay? All right, awesome. So now we're going to do another set of lines. And we're going to look at let's do y equals x plus 2. So again, you're going to do your table of values. I'm going to put the other ones up here. And then what I'd like you to do is just press pause on the video, complete your table of values, and then come back and check if you are getting the same answers or the same values in your table as I do. And remember, we're going to use the same x values all the time. And because x is our independent variable, those are the ones we pick. Oops, I'm missing one here. Go 1 and then 2. Okay. Okay, so once you have your table of values completed, so I'm going to use the same color combination for my lines as I did earlier. Now we're going to graph the lines the same way we did before. So again, press pause on the video, graph the lines, come back and check if you are getting the same ones or getting your lines looking the same as what I have. So just so you can check whether you are understanding that part. Okay, so we've got our system of axes. I'm going to plot my lines. So make sure you've pressed pause, plotted your lines, and then come back to check. Okay, so here's where now we're going to start drawing or coming up with some conclusions or observations. First, we're going to write our observations, and then we can draw some conclusions based on these lines. So we're going to have a similar table to what we had. So we'll write out our line. The first one was y equals x plus 2. So here, the m value in y equals mx plus b. So here, what am I multiplying the x by? Because that's what m is, right? So I'm multiplying the x by, and it's not nothing, it's 1. So my m value is 1. Now we're going to look at determining the slope from looking at the graph itself. So here, I'm going to pick 2 points that I can see clearly. I can see clearly what's on my x-axis and what's on my y-axis. So I'm going to go up. And remember, you can't count your squares because it's not a square as a unit. So you're going to count your units. So here the slope, I go up by 2. My rise is 2. And my run is also 2. And 2 over 2 is 1. So I'm just going to put like a little hint here because your slope is rise over run. Whenever the line is drawn, then you're going to use rise over run, unless you can't see points clearly. Then you go to use the formula from the last lesson. Okay, so now we're going to do y equals a half x plus 2. So here, the m value is half, so 1 over 2. And now we're going to determine slope. So from my orange graph, I'm going to erase the dots that I have from my blue one. And from my orange line, I go up and across because those are 2 clear points. And so my rise is 1 and my run is 2. And so it's just 1 over 2. That doesn't simplify, okay? And I think I just want to change this so this is also in orange. So it matches what we are doing. Okay, there. And so then in my magenta graph, we had, I think it was 2x plus 2. And I'm just going to erase these dots so they're not going to be in the way of what we're doing here. So now I can see this point really clearly, and I think I'll just go all the way up to here as well. Okay, so looking at the equation for the line, my m value is 2. Looking at the graph, and for some reason I have somehow erased this too. Okay, now looking at the graph, when I did my rise and my rise was 4, my run was 2. That simplifies to give me 2. So looking at the 2 columns we have here, the conclusion that we can draw is we can say, therefore, and y equals mx plus b, the m value is the slope. Okay, so what we're going to look at right now is just a little bit on function notation. And function notation is just the way we can write the definition of a line, or any function for that matter. And in this case, the functions we're talking about is a line. So function notation I'm going to create some space for us to write. Okay, So function notation is given like this. F with these brackets x. Sometimes it'll be g, sometimes it'll be h. When we look at linear relationships in real life scenarios, sometimes we'll be talking about cost. So then we might use c. But in any case, the way this is read, so the way you read it is f of x. Okay, and that's important for you to understand what function notation looks like. Okay, so for example, if we were to consider a function like this, okay, and I ask you so determine the value of f when x equals -1. Well, what I'm asking you for then is to replace x with -1. So that would be finding f of -1 because now x is -1. Okay, so if I want f of -1, that means everywhere where I see x, I replace it with a -1. Now here again, you do not show me step by step by step. You do a substitution. So that's the first line, like I've shown you. And then you let your calculator do everything else. So you should be putting this into your calculator using the brackets the way I have, and it will give you the correct answer. So press pause on the video and put that into your calculator and see what you get. And what you should get is -5. Okay, so that would mean, what this means is that, and so in this question, you wouldn't need to give me a therefore statement. I'm writing this so you understand what this means. So therefore, at x equals -1, the graph is at -5. So the point, so this means that the point is -1, -5. So let's just say that our function was talking about the height of something. All right, then its height would be -5. So that would mean that it's like lower than wherever it started. Okay, and that is what that would mean in a like visual sense. So we could give you a question saying, you know, this function is it represents the path or the flight path of an object that's thrown in the air, and what is the height at x equals -5 or something like that. So this is basically what that would mean. Okay, and so point wise it would be on the Cartesian plane at that point, because remember x and then y. So that means the function, the f value, gives you basically the y value of your graph. Okay, so we're going to see if we can put together the things that we learned in what do m and b mean in the equation of a line. So here we want to figure out the equation of this line. So we just have to remind ourselves and at the beginning of this video, I mentioned that there's different ways that we express the equation of a line. This form is called slope-intercept. Because it gives me the slope and the y-intercept. And that's why we call it slope-intercept form of the line, okay? Okay, so remember what m and b stand for. M represents the slope and b represents the y-intercept. So looking at my graph right away, I can read off what b is. My b value is 3 because that's my y-intercept. And then to determine the slope, we are going to calculate rise over run. And what we're going to do then is we're going to find 2 points that we can see clearly on our graph. And when you're looking for 2 points that are clear, you start on the left-hand side because we read from left to right. So a point that I can see is over here, and I'm going to pick another point that I can see as up there. And then we count rise over run. So rise is upwards. Sometimes your rise will be negative, as you saw in the previous lessons examples. So this is my rise. And in this grid, it's 1 square is 1 unit. So I can just count 1, 2, 3, 4. I'm actually going to color code this so that it's the same color as what I did as rise. So our slope is 4 over, I need my run. So let's use that for my run. And as I go across, that's 2 units across. So this is my run. And so it's 2 units across, and I'm moving to the right. So it's also positive direction. And so you get 4 over 2, which gives me 2. We don't write 2 over 1. Okay. So therefore, the equation of the line is y equals 2x plus 3. Now you don't have to write the whole thing. You don't have to write the equation of the line is. You could just write y equals 2x plus 3. You don't need to write all the words because this is not a word problem. Okay. Now, just to remind you of a few things, all right, and that is that when we talked about slope in the previous lesson, I mentioned how if your line is going upwards, as if you are going up an escalator or climbing upstairs, your slope will be positive. And if your line is sloping downwards, like you're sliding down a slide, then your slope will be negative. These are important observations because if we did our working out in this graph and we got a negative answer for slope, immediately we know something is wrong because our graph, remember, and we read right, left to right, so there shouldn't be any ambiguity. You approach your graph from the left. So if I look at it from the left and I'm going upwards, which means my slope has to be positive. Okay, so if you have an upwards line and you're getting a negative slope, then you know your calculations are wrong. Okay, likewise, if you had a graph that was moving downwards and you got a positive slope, then you would know that you're doing something wrong there. Okay, and that's just a way for us to kind of troubleshoot the answers that we get. Okay, so make sure you've taken these notes down.